and welcome, and in this video we're going to be talking about the properties of logarithms. Now the properties of logarithms are very useful, especially when we try to solve certain logarithmic equations, as well as some exponential equations. Now the first thing I actually want to talk about though is I want to refresh your memory on some of the properties of exponents, and now we can kind of see how similar these properties actually are. So let's talk about the properties of exponents. Well, the first one that you should be familiar with, I really hope you're familiar with, is the product property that states if you are multiplying two exponential expressions with the same base, you add the exponents, okay? So if you have the same base, you are adding the exponents. So for example, I have x squared times x cubed. The base of both is x, so I add the exponents of 2 and 3 to get x to the fifth. We should be very familiar with the product property. We use it a lot, especially when we talk about polynomial functions, when you FOIL and all that stuff, you're using the product property. Now, one that people forget a little bit, quotient property, which states if you're dividing two exponential expressions with the same base, you actually subtract the exponents. This one's a little bit more forgotten. So if I have something like x to the fifth divided by x to the second, notice the base of both are x, so I subtract the exponents of 5 and 2 to get x to the third. And now there are some others, but the last big one I want to talk about is the power property, which states if you have an exponential expression raised to some other exponent, you actually multiply the exponents. So for example, if I have x squared and then that is raised to the third power, we actually multiply the two powers. If you have a power raised to a power, you multiply the powers. So if I have x squared raised to the third, I multiply the two powers of 2 and 3, and that becomes x to the sixth. Now those are the main properties of exponents. And remember, the inverse of an exponential expression is a logarithmic expression. So let's talk about the properties of logarithms, because we have one for each of them. There is the product property of logarithms, and it's actually kind of remarkably similar. Now with exponentials, if they had the same base, you added the exponents. Well, with logarithms, if you have two logarithms with the same base and you have two logarithms adding one another, you can actually condense the logarithms. That's what we call condense. We're taking multiple logarithms and we're condensing it down to a single logarithm. Then you actually multiply the arguments. Notice here you're multiplying exponential expressions, you're adding the exponents. Here you're adding the logarithms, you're multiplying the arguments. So kind of flipped, right? So that is a product property of logarithms. For example, if we have log base 2 of 4 plus log base 2 of 3, that becomes log base 2 of 12. The base of both of these logarithms would be 2. So since they have the same base, we multiply the arguments to get log base 2 of 12. And that's the product property of logarithms. Well, there's also a quotient property of logarithms. Now in exponentials, if you are dividing exponential expressions, you subtract the exponents. Well, with logarithms, if you're subtracting logarithms, you're dividing the arguments. So it's like literally the exact opposite, but they're very, very closely related. So if you're subtracting two or more logarithms, and they all have the same base, you can condense it to a single logarithm by dividing the arguments. So for example, if I have log of 20 minus log of 4, remember those are the common log, base of 10. We divide the arguments of 20. 20 divided by 4 gets us 5. That condenses to log of just 5. And now the power property might be the one that is a little bit tricky at first, but it starts to kind of become second nature. With logarithms, the power property states if you have a logarithm and inside that logarithm, your argument actually is raised to a power, you can actually bring that power out in front, as we can see here. So for example, if I have the natural log of 4 to the third power, I can bring that 3 out in front and make that 3 times the natural log of 4. And those are your three properties of logarithms, but who cares? Let's use them now. So what we're going to be doing is we're going to be doing what we call expanding and condensing logarithmic expressions. Expanding means we're going to take a single logarithm and expand it into multiple logarithms. And condensing means we're going to be taking multiple logarithms and condensing it down to a single logarithm. So I want to go over a couple of problems. I'm going to make these a little bit more simple, and if you have questions, make sure you're letting me know. So let's go ahead and take a look at a couple of problems. Okay, so let's go ahead and take a look at a couple of problems. Now, first we're going to be talking about condensing, taking multiple logarithms and boiling them down to a single logarithm. So in this example here, we have log base 3 of x plus log base 3 of 5. Now, it's important to note that the base of each logarithm is the same. If they were different, we actually wouldn't be able to do anything. But because the bases are the same, we can condense these two. Now, whenever you have two logarithms with the same base adding one another, what you can do is use the product property. And the product property states if you have two logarithms adding one another, you multiply their arguments. So this is going to boil down to a single logarithm, log base 3, the base never changes. Log base 3 of, and the arguments x and 5 multiply each other. So x times 5 is 5x, so that would end up being our final answer. That's it. We multiply the arguments. X times 5 is 5x. Let's take a look at another one. So for example, let's say we wanted to condense log base 7 of b minus log base 7 of r. Well, in this problem, we have two logarithms, both base 7. That's important. So since they have the same base, we can condense these. And now what we can do is use the quotient property. When you have two logarithms with the same base subtracting one another, what you can do is condense using the quotient property, which means you divide the arguments, okay? So what this is going to become is log base 7. Now, the positive logarithm always ends up in the numerator, and the negative logarithm always ends up in the denominator. So notice how log base 7 of b is positive. That's going to stay in the numerator. And log base 7 of r is negative, is subtraction there. So r is going to be in the denominator. And this would end up being our final answer, log base 7 of b over r. Now, if you can simplify that argument, like if it was like 4 over 2, make sure you do so and make that 2. Or if you had like 10 over 5, make that 2. I'm using bad examples. All of them are ending up to 2. Let's say something like 20 over 4, make that 5, okay? And I like to put parentheses around my argument just to be safe. Now in this next one, we're trying to condense 4 log of x plus log of y. So now we're going to start mixing them up. Well, in this one, the first thing I'm noticing is that there's a 4 in front of log x. What that means is that there used to be an exponent on x. We can use the power property first to start to condense this. So what this is going to be is log of x to the 4th. We can bring that 4 as an exponent on x using the power property. They work both ways. And that's going to be plus log of y. And now I can actually go even further. I have two logarithms adding one another, and they have the same base. These are both common logs with a base of 10, which means I can now multiply the arguments. So this is actually going to end up being equal to log of x to the 4th times y, which is just x to the 4th y. Okay, that would be our final answer. Now let's try one more and make this one a little bit more interesting. So we have 4 natural log of a plus natural log of c minus natural log of b. Once again, these all have the exact same base, so we can condense all 3 of these into one logarithm. Now the first thing I'm noticing is that I have some coefficients. You can kind of think about them as coefficients in front of the logarithms. So I can use the power property to bring those on their arguments. So the first thing I'm going to do is I'm going to make this a natural log of a to the 4th plus a natural log of c. Notice that one didn't have a number in front, so I don't have an exponent, minus the natural log of b squared. Now I'm going to start breaking this down and condensing. The next thing I can do is I can recognize, hey, these two logarithms are adding one another, which means I can multiply their arguments using the product property. So I can make that the natural log of a to the 4th times c minus the natural log of b squared. And from there, I still have two natural logarithms, so I can condense them. And notice they are subtracting one another. So I can go ahead and divide their arguments to get the final answer of the natural log of a to the 4th times c all divided by b squared. And that would end up being our final answer. Now, the next thing I'm going to do is I just want to take a look at a couple of examples of what's called expanding, when we're actually going to be given something like this, and we want to expand it back to multiple logarithms. So let's go ahead and take a look at that. All right, let's go ahead and take a look at some expanding ones. So in this one, we want to expand log of xy cubed. Now with expanding, we are going to try to have multiple logarithms, basically one logarithm for each variable or coefficient on a variable, basically, okay? So in this particular one, I notice that there's two variables, x and y, so I'm going to have I'm going to have two logarithms. One of them is going to be log of x, and x was multiplying y to the third. Well, since they were multiplying, that means that the logarithms are adding one another using the product property. So I have log of x plus log of y cubed. Now, I actually also, whenever I expand, I actually don't like having exponents on the arguments. So the next thing that we can do is take this exponent and move it out in front. So this would end up becoming log of x plus 3 times log of y. And that would end up being our final answer. So our final answer should always have multiple logarithms, and we shouldn't end up having any exponents. Let's take a look at another one. Let's say the natural log of a squared divided by b cubed. Well, right away, I'm noticing that I have a and b, so I have two variables. I'm going to have two logarithms, and they're dividing one another, which means that the logarithms we're subtracting using the quotient property. So that would be the natural log of a squared minus the natural log of b cubed. And one thing I want to point out real quick, let me go ahead and separate these. One thing I want to point out real quick is notice that the a squared is positive and the b cubed logarithm is negative. Basically, any logarithm, anything that's in the denominator of an argument, its logarithm is going to be negative once you expand it. I kind of want to throw that out there because it's going to help you out a lot. Some of you might be able to start seeing shortcuts and go straight to your final answer. That's excellent. If not, take it step by step. Because the next step here and the final step here would be realizing that we have exponents that we could bring out in front using the power property. So our final answer would end up being 2 times the natural log of a minus 3 times the natural log of b. And our final one, log base 2 of x squared divided by y cubed times z. Now this one I'm actually going to kind of skip and show you guys some little tricks you can do, okay? Now, you could take this step by step, so feel free to take it step by step, but I'm going to kind of break it down and tell you how I see it. The first thing I see is that I see x squared in our numerator. What that means is that eventually I'm going to have 2 times log base 2 of x. That is in the numerator, so that logarithm will be positive. There will not be a subtraction sign in front of it. That would have been x squared, but that 2 would have to be brought out in front. So I'm going to go straight to 2 times the times log base 2 of x. Now, the next thing I'm noticing is I'm seeing two variables in our denominator. So that tells me I'm going to end up having two logarithms with subtraction, okay? So that's one thing I can see right away. Now, another thing I can see is that I have y cubed here. Well, that third power, I can use a power property to bring out in front of that logarithm. So what I would actually have is minus 3 times log base 2 of y minus log base 2 of z, and z had no exponent, so there would be no number out in front of it. So that would be your final answer. And let me make that maybe a little bit nicer looking. 2 log base 2 of x minus 3 log base 2 of y minus log base 2 of z. That's just kind of a nicer written out one. So that would end up being our final answer. And that's properties of logarithms, guys. It takes a little bit of practice. I hope this video helped. If there's any questions, please feel free to let me know. I can make another video with some more examples. Please feel free to reach out. But until next time, I look forward to seeing you guys in the next video.